Hi everyone. Today we're getting into our unit circle. So we're just looking at like a little introduction on how do we make a unit circle and what is a unit circle. You've got, after today, I want you to be able to draw angles in your standard position. I want you to be able to find coterminal angles and also use some radian measure. All right. What I need you to do in like the next 2 days is I want you to be really fluent in a unit circle. All right. I want you to know the unit circle forwards and backwards and radians and degrees and decimals, all of it. Okay. It'll help you from here on out in all of your math career. All right. So angle basics. We start off, we've got an angle. You have a ray that we're going to call the initial side of your angle, and then this terminal side opens up to form the angle of theta. And our standard position is when your initial side, or when the vertex of your angle is at the origin, 0, 0, and the initial side lies along the positive x-axis, which I'll show you in a second. And moving in a positive direction is always counterclockwise, the opposite way the clock moves. All right. Moving in a negative direction would be going clockwise. Please keep that in mind. That's super important. All right. So we're going to get into drawing a few basic angles. So we're going to put our vertex at 0, 0. Our initial side is always the positive x-axis. And we're going to open up an angle, maybe like right here. So if this angle opens up to be something like 30 degrees, for the most part on our unit circle as we build it, you're going to see the degree over to the right-hand side. Okay? So there's a 30-degree angle. If you're looking for an angle that is 180 degrees, you have to think about, well, we're on a circle here, right? We have our initial side along the x-axis, and all the way around a full circle is 360 degrees. All right, so 360 degrees and 0 degrees are what we call coterminal angles because their terminal side lies in the same place. So half of 360, right, your semicircle, let me erase that, whoops, would be opening up from your initial side all the way down, and it'll lie along the rest of the x-axis, so that'll be 180 degrees. And likewise, half of that would be 90 degrees. All right. So when you're looking for maybe, when you're looking to draw an angle such as 150 degrees, what you want to look at is which quadrant would that be in. All right. You've got the first quadrant. Oops. Are angles between 0 and 90. Your second quadrant would be angles between 90 and 180. And then think some more, you can have 270. That's an angle all the way down here, right? That would make up your angles between 180 and 270 in your third quadrant. And in your fourth quadrant, you're going to have angles between 270 and 360. So find me a 150 degree angle. I would look at it as, well, if I went 180 degrees and went backwards 30 degrees, okay, I have myself an angle from the initial side all the way to the terminal side of 150 degrees. Okay. So this one's 150 degrees. This little 30 degrees right here, this has a special name. It's the angle that is formed with the x-axis. So right here, this angle is 30 degrees. We call that the reference angle. So it's the angle that 150 forms with the x-axis. We'll talk more about that in a second. Let's build ourselves our full unit circle in degrees. So we're going to move in a positive direction first. And we start out, we've got 0 degrees, all the way to 180 degrees, all the way back around to 360 degrees. Okay, we know that an angle right here, that would be 90 degrees. And then if you continued all the way down, like we just talked about, this angle would be 270 degrees. Now there's a bunch of other lines drawn. We've talked about this angle. That is our 30 degrees. And then if you added another 30 degrees, boom, you're going to be at 60 degrees. And then if you add another 30 degrees, you're at 90 degrees. And continue this pattern on. From 90, add 30 degrees, and you get 120 degrees. Add another 30 degrees, and you're at our 150. Add another 30, you're at 180. Keep going. From 180, add 30, you get 210. From 210, add another 30, you get 240. Keep on going. 240, add 30 to get 270. Keep on plugging along. Here's an angle of 300 degrees. Add your last 30 before you hit 360 and you get 330. And you're all the way back around at 360. You'll notice that I skipped a few, right? So 30, 60, here's your 90, 120, 150, 180. Okay, so I'm going to highlight the little slices of pizza that are all 30 degrees, or where your central angle is 30 degrees, because I skipped a few. Let's highlight this one. So if I go this angle, we're going to call this one that opens up from the initial side, and its terminal side has an angle of 45 degrees. Okay, so we're going to do the same thing we did with the 30 degrees and add 45 all the way around. Okay, so 45 plus 45 gives you your 90 degrees. Check. From 90 degrees, add another 45 degrees, and that would be 135 degrees. And then add another 45 degrees, and lo and behold, you're at 180 degrees. Keep going. Add another 45, and this little ray right there would be 225 degrees. And then keep adding. 45, you hit 270. Add another 45 degrees, you get 315. And so that is this one. Add another 45 degrees, and you just made it all the way around to 360. Now, what would happen? Can you have angles that are bigger than 360? Sure, why not? You can take some spins around that unit circle. You could have an angle of 900 degrees. Okay, it would just be a few spins going in a positive direction. Remember, positive direction goes counterclockwise. And you can also go backwards on a unit circle. So that is your complete unit circle in just degrees. Now we're going to build our unit circle in a negative direction. So this time our angles start with an initial side of our positive x-axis, but instead of going counterclockwise, we're now going clockwise. So we're going like that. Okay, so we're going to go an angle this direction would be a what we call negative 90 degrees. We know it's negative direction because of the negative sign. And then keep going. We've got our negative 180. We've got our negative 270. Make sure we add degrees sign. And then all the way around would be a negative 360 degrees. And then we can kind of fill in all the other angles also. So let's start off with our 30s, like we did before. Going in a negative 30 degrees first, that would be that angle. Add another 30, you'd be at negative 60 degrees. Adding another 30, or negative 30, you would be at negative 90, and then continue on. Add another negative 30, you would now be sitting at an angle of negative 120. Keep going. Negative 150, add another negative 30, you get negative 180. Keep going. You can probably fill this in at this point, negative 210 degrees. I'm dropping some degree signs. Fill those in. Keep going, add another negative 30, you get negative 240. And the next one you hit negative 270, continue on. You get negative 300 degrees. Next one, negative 330. And all the way back around, you're at negative 360 degrees. All right, and let's backfill our 45-degree angles. Okay. So right here, they're at the 45-degree angles. Whoops. So negative 45 degrees, add another negative 45 degrees, and you hit your negative 90. Add another negative 45, and you get your negative 135 degrees. Keep on going. Add another negative 45, you're at negative 180. Add another negative 45. You get negative 225. Add another negative 45, you're at negative 270. Keep on going. You probably are seeing the patterns all over the place at this point. You got negative 315 degrees. And all the way back around, you're at negative 360. All right, so we just built it forwards and backwards. Now let's talk about those bigger angles. If you want to draw an angle with the given measure in standard position, we'll start with part A. Let's look to draw 225. You're going to notice that 225 is positive, so we want to make sure we're going in a positive direction, which is our counterclockwise direction. We have our initial side along the positive x-axis, and we're going to open up to angle 225. So you can count. Here's your 90. Oh. Here's your 180, and we're going to go slightly more. So it's somewhere in the third quadrant. That's an angle of 225 degrees. So there you have it. That's an angle of 225. One further question that I could ask is, what's a referenced angle of 225? And what you would be looking for, let me change colors. The reference angle is the angle that's formed with the x-axis. So that is actually this angle that gets back to the x-axis. You always want to get back. All right. So how do you figure that out? Well, you take, if this guy's 225 degrees and we subtract the 180 degrees, that's your difference. 225 degrees minus 180 gives you a reference angle of 45 degrees. All right. Let's go and do part B now. Let me erase all that. If you've got 675, all right, so 0 degrees, 360 degrees, what would that look like? 675, I usually for these guys, I'm going, well, obviously it's around the circle at least once. So 360 degrees, I rotate it around, and then I need to go more. So add 90 to 360 degrees, and that's not enough. Add another 90 degrees, and you're not quite there. You got to keep going, and it's around here. We've got your terminal side would be in technically the 1, 2, 3, 4, 4th quadrant. Well, technically 4th, 5th, 6th, 7th, 8th quadrant, technically. And 675 would be right there. So it's one spin, almost 2 spins around the unit circle. If I asked you for the reference angle of 675, I would be looking for the angle that's formed with the x-axis here, the pink one. It's acute. I would probably want to think about, well, 360 is coterminal, or it ends at the same place as 720, which is 2 spins around the unit circle. If you take 360 plus 360, 720 would be coterminal with 360. So I'm going to take, to find my reference angle, I'm going to take that 720 and minus the 675 degrees, and that would be 45 degrees. So 45 degrees. So my picture's slightly off a little bit, but I think you get the right idea. Moving on to part C, if you have a negative 160 degrees, let me erase some of this. We are now moving in a negative direction, so I'm actually going to erase all my positive degrees as well. So this time for negative 160, we have our initial side, and we're going to go in a negative direction. So now we're moving in a clockwise rotation, and this would be your negative 90 degrees, negative 180 degrees, and you're going to know that negative 160 is not quite to negative 180. So we've got an opening up all the way down in a clockwise manner, and it'll be somewhere around here, negative 160 degrees. So if this angle is 160 degrees, our reference angle would be the angle that's formed with the x-axis, and that would be negative 180 minus a negative 160, or really just adding, or just find the difference between 180 and 160, and you get 20 degrees. And just make sure your reference angle is positive. Sorry, this negative 160 needs a negative sign. All right, and our last part D is 690. So we're going back to positive spinning. Erase my negatives. All right, so 690, where would that put us? We would go 0 degrees, 90 degrees, 180 degrees, 270, and we're taking extra spins around our unit circle. So 360 degrees, keep going. It's going to get real close to 2 spins of 270 degrees. And you'll see that it's further, it's actually closer to the x-axis than part B, the 675. So it's about here. So we've got 1, almost 2 spins would be our 690 degrees. And that angle would have a reference angle of 720 minus your 690, which gives you a reference angle of 30 degrees. Okay. All right, so hopefully that makes some sense because we're gonna talk a little bit more about coterminal angles next. So what's another angle that has the same terminal side as 690? 690 has a reference angle of 30 degrees, right? So one spin around the unit circle, 690 would be coterminal with R330. They end at the same place. Just like 0 and 360, the terminal side ends at the same place. Likewise, 0 degrees, 360 degrees, and 720 are also coterminal. Another way to look at it is if I had, let's say, an angle of 90 degrees, another coterminal angle, if I spun around the unit circle and I ended up at that 90 degrees, that would be 90 degrees plus a full spin of 360 degrees, which gives you another coterminal angle of, that gives you 450 degrees. So 450 degrees and 90 degrees are coterminal. All right, let's define that for you guys down here. So coterminal angles are just angles that have the same terminal side, aka they end at the same place. For example, 30 degrees and 390 degrees. So we can find one positive angle and one negative angle that are coterminal with negative 75. So if you took the negative 75 degrees and added one full spin around your unit circle, you would be adding 360 degrees to that negative 75, and that would just be 285 degrees. Now, if you wanted to find another positive angle that's coterminal, you would take 285 and add another spin around your unit circle of 285. So 285 plus 360 would give you another coterminal. Now, what if you took that negative 75 degrees and wanted a negative coterminal angle? You would just subtract a full spin around your circle of 360 degrees, which would give you a negative 435 degrees. So coterminal angles have the same terminal side. And just for extra practice, you've got 395. If you wanted another positive angle that's coterminal with 395, yes, you can just add another 360 to that, and you'll get like 2 or 3 spins around your unit circle. But even you could still subtract a full spin out of 395, and you would be left with a coterminal angle of positive 35. So that's a little tricky. And to get down to the negative coterminal angle from 395, you have to actually subtract not one negative spin, or not one spin around the unit circle, but technically 2. So we'll take that 35 degrees now, that already subtracted one spin, and subtract another spin, and I get negative 325 degrees. All right, just as a little recap, you've got standard position, your center, your vertex is at 0, 0. Your initial side is along the x-axis, and that is fixed. It does not move. Okay? Your moving ray is the terminal side. So it's movable, and that's in green. Now let's move on and talk about radians. So angles can also be measured in radians. We know that the circumference of any circle is 2 pi r. So let's build our unit circle using radians. Our unit circle actually has a radius of 1. So if you think about that, when you plug in a radius of 1 into 2 pi r, your circumference is just 2 pi. So what a radian actually is, it's just the measure or the length of the arc. So we have 0 radians, and remember, going in a positive direction, we're counting counterclockwise, okay, all the way around your unit circle. If your radius is 1, would be 2 pi. So we can do what we did with degrees, but now in radians. So if you think about, if all the way around is 2 pi, then half of that would be pi. And then you want to cut that up even further, and your semicircle gets cut in half, and now you're going from your initial side to what is 90 degrees, but in radians that would be half of pi, which is pi over 2. All right, and you can see this pattern happening, right? You go, here's a half of a pi, add another half of a pi plus half of a pi is a full pi. And then you add another pi over 2, and you get 3 pi over 2. And then add another pi over 2, and you're at 2 pi all the way around your circle. Now, we're going to do the same thing with our other radian measures. So if you want to look at your pi over 4, you want to think, where would that be? I'm going to erase a little bit. Take a look at this measure right here. We're going to cut up our unit circle into eighths, pretty much. So each piece is a fourth, right? Because if you are looking at this angle, which is pi over 2, half of that, which is equivalent to 45 degrees, would be pi over 4. So you can go around your unit circle adding pi over 4s. So that angle right there is pi over 4. Add another pi over 4, you get pi over 2. Add another pi over 4, and that will be 3 pi over 4. And then, of course, 4 pi over 4 is equivalent to a pi. And now you're at 5 pi over 4. Add another, so we're all the way around here. Add another pi over 4, which is technically 6 pi over 4, but you know that simplifies to be 3 pi over 2. Keep going. 6 pi over 4 plus another pi over 4 would be 7 pi over 4. And all the way around in fourths would be 8 pi over 4, which is already simplified to be 2 pi. All right, so that's like your unit circle cut up into fourths or pi over 4s. Now let's go and do our angle measures that are equivalent to 30 degrees and our 60 degrees. Let me erase a little bit. Erase that. We'll leave those. Take that. All right, so gonna change colors. Let's cut up our circle into our 30 degrees. So each one of these are all increments of 30 degrees, right? So almost done. Think about, if you look at the top of, of our unit circle, right? That's a full pie. How many pieces of pie is it cut up into? 1, 2, 3, 4, 5, 6 pieces. So one slice, if you think about it in terms of pizza or whatever your favorite circle food is, would be pi over 6. And then add, so that is this angle right here. And then add another pi over 6, you get 2 pi over 6, which I want you to simplify that to be pi over 3. And then add another pi over 6, and that is at 3 pi over 6, which you know is already simplified to be pi over 2. Keep going, add another 4 pi over 6, but we can simplify that to be 2 pi over 3, which is the one I want you to really know. Keep going all the way around. So we're at 5 pi over 6, and then 6 pi over 6 is equivalent to your pi, and 7 pi over 6, and then 8 pi over 6, which we're going to simplify. That is 4 pi over 3. All right, add another. We're at 9 pi over 6, which simplifies to be your 3 pi over 2. Keep going. 10 pi over 6, which we're going to simplify to be 5 pi over 3. Almost done. Keep going. We're at 11 pi over 6, which doesn't simplify, and all the way around your unit circle in 6 pi over 6's would be 12 pi over 6, which of course simplifies to be 2 pi. Okay, so these ones kind of brought in, I'm going to erase some of the extra ones that we don't really need. So to clean it up a little bit for you, 4 pi over 3, don't need that one. Oh, deleted that one. I'll just rewrite that one. That is 5 pi over 3. All right. So these are your most simplified radian measures for your unit circle, and this is going in a positive direction. Of course, we can flip it around. Everything goes in the opposite direction if you add some negatives. All right, so quick fill that in. If you start at 0 and go in this direction, your first angle you would run into is negative pi over 6. And then negative pi over 4, and then negative pi over 3, negative pi over 2. So just cruise around your unit circle just in a negative direction. Negative 2 pi over 3, negative 3 pi over 4, negative 5 pi over 6, negative pi, negative 7 pi over 6, negative 5 pi over 4, negative 4 pi over 3, negative 3 pi over 2, keep on plugging along, negative 5 pi over 3, almost there, negative 7 pi over 4, and negative 11 pi over 6. And end, negative 2 pi. So what I want you guys to understand is that this radian measure is actually the length of the arc, how long it is, right? Because our radius of our unit circle, a 1 unit circle, is 1. We have all the way around is 2 pi. Now, this is when I want you to not really use decimals in general. I want you to leave these in simplified fraction form and just work with them. We can switch between radians and degrees. So you know that 2 pi is equivalent to 360 degrees, so there is a way to switch between radians and degrees. You should be flexible going from radians to degrees and degrees back to radians. Okay, so we know that radians are equivalent to 360 degrees over 2 pi. And you can simplify that fraction, so we know that a radian is just equal to 180 degrees divided by pi. Here's a little helpful hint on conversions between degrees and radians. So if you want to convert from degrees to radians, you're going to be multiplying the degree by pi over 180 degrees. Now, if you're switching back from radians back to degrees, you're going to be multiplying the radian by 180 degrees divided by pi. So let's practice that a little bit so you see what I'm talking about. If you wanted to get the radian measure of negative 150 degrees, you take that negative 150 and you're going to multiply by pi over 180. And simplify that, you get negative 150 pi divided by 180. So that simplifies to be negative 5 pi over 6. And you can compare that on your unit circle. Scroll back, negative 150 degrees. When we were going in the negative direction, negative 150 is right there, which is equivalent to your negative 5 pi over 6. And right now, 9 pi over 4 is in radians, so we want to switch our radians of 9 pi over 4 back to degrees. So we're going to multiply by 180 divided by pi. And you'll see your pi's will cancel. And simplify that. That will be, use your calculator, it's fine, 405 degrees. Now, when you take a look at C, you're like negative 6.28. Wait, that is missing a degree sign. So if you don't have a degree symbol, you are in a radian. Please, so you can actually type in your radian and round to the nearest, in this case, 100th, and get a decimal version of the radian. So what you need to remember is if there is no degree sign, you are not in degrees. You are in radians. Okay, so switching from our radian of negative 6.28, we're going to multiply that by 180 divided by pi. And that ends up to be 359.8 degrees. So, you guys, as you do your homework, make sure you put a degree if you are talking in degrees. If you're not talking in degrees, please leave off the degree. That brings up a little bit more about our unit circle because we can now build our unit circle in decimals, all right, which are radians. Okay, we can go in a positive direction or in a negative direction. So starting off in the positive direction, you've got 0 all the way around your unit circle, 2 pi. Enter 2 pi into your calculator and round it, 6.28. So then halfway around your unit circle would be 3.14. Hey, we've seen that before. That's just pi, which makes sense, right? And half of that would be 1.57, and filling in pi over 6 would be 0.52, pi over 4 would just be 0.79, pi over 3 would be 1.05, and so on and so forth. 2.09, 2.36, I'll just type them all in for you. Oh, maybe 2.62, 3.14, so then 3, why is this doing this? 3.67, keep going, 3.93, having some problems. 4.19, your 3 pi over 2 would be equivalent to 4.71, 5.24, 5.50, and 5.76. So that's all in a positive direction, and you can likely fill in the negative direction because you probably get the hang of it by now, so make sure you're going counterclockwise and using negatives. So 0 and negative 6.28 would be all the way around, and fill it in backwards. Negative 0.52, negative 0.79, negative 1.05, negative 1.57, negative 2.09, negative 2.36, All right, and then the last little bit we need to talk about is bringing up the idea of a sector and our central angle for that you've learned in geometry. So you know a sector is just a region of a circle that's bounded by 2 radii and an arc of the circle. So you've got a sector, it's like a slice of pizza. It's that blue highlighted right in there. It's formed by the central angle of the sector. And there are 2 simple formulas for arc length, which is radian. Radian is arc length, and the area of a sector when the central angle is measured in radians. So this is taken off of the unit circle. We're not talking about a unit circle. This is just of any circle in general, that the arc length is just the radius of the circle multiplied by your central angle, and then the area of that sector is 1/2 r squared, which is the radius, multiplied by your central angle. And this is when your theta, your angle, is measured in radians. Oh. Okay. One example is, of course, our softball field. Our softball field is actually a sector out of a circle, and it has think of this as the center of your circle. It's got a radius of 200 feet in all directions, and at home plate you've got a 90-degree angle, and we want to find the length of the outfield fence and the area of the field. So the length of the outfield fence is the piece of the circumference, which is our arc length. So first off, we're going to switch from 90 degrees and speak in radians so we can use the 2 formulas that we just talked about above. So 90 degrees multiplied by, looking here, 90 degrees multiplied by pi radians over 180 is just pi over 2. And that makes sense because we think back to what we just talked about, and 90 degrees was definitely equivalent to pi over 2. So you will have that memorized here pretty soon. All right, moving on, we're going to find the arc length, which is the length from all along the outfield fence. All right, so you take 200, which is the radius, and multiply it by your pi over 2. Simplify that down, and you get 3.14 feet. Now to find the whole area of that sector, which is the whole slice of the ball field, you take 1/2 your 200 squared multiplied by your central angle of pi over 2. Simplify that down, and you get 31,416 feet squared, since you're talking area. All right, well, we're going to talk a lot more about unit circle in the coming days, so I'm sorry this one was kind of long, but